and we're dealing with transformations. We dealt a lot with this in Algebra 2, and we're going to kind of fly by it. Let's do a quick review on basically what we've got. So if you're subtracting a value inside, then if C, not the minus C, but if C itself is positive, it moves the graph C units to the right. Conversely, if C is negative, then it moves C units to the left. And if C is negative, then this sign right here will become a positive. So I've got the function, I'm multiplying x by some constant. So if, now notice here I'm changing the value of x and not the value of y, of f of x, just the value of x. So if a is greater than 1, this is a horizontal compression. And basically, if a is a fraction, it's bigger than 0, but less than 1, then it's a horizontal stretch. Remember, the numbers inside tend to work the opposite of what you think they are. Okay. So I take my function, and I'm going to add some constant. Notice this is to my y value. So if C is positive, it moves the graph up C units. And if C is negative, it moves it down C units. All right. The last thing then is I'm going to multiply my y value or my function value by some number. So if a is greater than 1, then this becomes a vertical, and it's vertical because we're messing with y, whereas up here we're messing with x. It becomes a vertical stretch. And if a is a fraction, then it's a vertical compression. You notice these things work backwards. Okay, so we've translated and we've dilated. Last thing then we're going to talk about is reflecting f of negative x. And so here again, I'm changing the sign of x. So that means it's going to reflect over y-axis. And the reason it does that is, let's say that was my x value right there. By changing it, I'm just going to move it over here. And you notice this is a reflection over the y-axis, because all we're doing is changing the signs. Conversely, if this was my point, then I would reflect it over to there, which is just changing the sign. So the next thing is negative f of x. So here I'm changing the sign of my function or y value. And it reflects over the x-axis. And you can make the same graphical argument here if I have a point here, which is positive, when I change its sign, it's going to plot down here, which is a reflection across the x-axis. Okay, last thing. Even functions. These things have symmetry across the y-axis. Or they can be written as f of negative x equals f of x. An example of that would be y equals x squared. A good old parent function if you graph it. This is an even function, and I think you can guess where the name comes from. You've got an even power, because we have symmetry across the y-axis. So if we've got even functions, the next ones are odd functions. And these things have symmetry not through the x-axis, but they've got symmetry through the origin. An example would be y equals x cubed. Let's take a quick look at what that would look like. And here I am through the x-axis. And you'll notice that this point right here, 1, 1, becomes negative 1, negative 1. And this is an example of odd symmetry, but it has to be through the origin, okay? And this point here becomes this point here, and this point here becomes this point here. And that's symmetry through the origin. Okay, and I'm going to add another function here. Now you notice this is the one I had before, but I've added 1 to it. And when you take a look at this thing, this does not have even symmetry, because we're not symmetric across the y-axis. If we were, then this point should have a point over here. We also don't have odd symmetry, because again, this point right there, if that was true, should be right there, and it's not. What's happened is because we've shifted up 1 unit, we're no longer going through the origin. I've got neither even or odd, and this is classified as neither.